Hello everyone. Today we are going to discuss about the Capstone Project 12. That is about building a local LLM based on real-time models such as Hugging Face. Before going into the classification, I just want to show where my dataset is coming from. The first dataset that I have taken and the uh, actual analysis that I'm going to do is about travel. So that is why I have taken about tourism chatbot for my project. So for this tourism chatbot analysis, my data set is coming from various places. That is, first one is from Kyle, that is TripAdvisor, that has hotel bookings, ratings, and reviews in the data set. That is a last data set. Uh, and the second one is coming from the Hugging Face, that is about cancel and refund uh, terminology for how a chatbot should chat with the customer or the client. And the next one is for the Hugging Face data set that is there, and that is about itinerary planning and budget allocation and estimation for the budget and safety for customs. All this Q&A will be there in a 5,000 domain-based uh, set. And there is also another set that is used for RAG implementation, that is NVK Voyage, that will be covered in RAG pipeline. So for now, let us deep dive into our project. So my project is what I've told you about, is the tourism chatbot, where we can chat with the chatbot about only that is only fixed towards uh, tourism, that is based on PHI 3 LLM platform that is available in the market. This is my GitHub link. That is what I have told you here as well in my problem statement, that I wanted to build an AI chatbot. Okay. Next comes the libraries. These are very standard libraries that I wanted to import for all the and yeah, sorry. Before converting into my dataset, I wanted my dataset so that my tourism GPT can uh, know all the values. So I wanted to convert all these data that is there in Excel and CSV data formats into JSON-L files. For that, I designed another pipeline in Python, where all the three data sets are being stored in this uh, format, and I will be getting out as a JSON-L format for 1200 JSON-L structures and generated in a output file. This output file is used in my uh, analysis and RAG implementation, or tuning the LLM, or showing it in the pipeline, or and doing any analysis on this. I've been using this uh, tourism GPT pipeline IPYNB. For that, I'm getting the .json file. This is my JSON-L file for the dataset. This is my dataset, but this is not complete because the 1200 dataset will not give exact output. So what I did is I wanted to print out more pairs. So I designed another generate AI pairs based on the 1200 pairs that I've got received. I wanted to find out more, and I wanted to increase the value of that pairs into around 2500 to 2600. So that is what I did. I generated pairs for for my data set, so that our chatbot would be focusing only on my data set and would be getting a last data to train on. So with this, I've generated few more pairs. I've given implementations as well for each section, and what all my data set covers. Around 6 7 sectors is what I've given it. So for that pipeline, after getting my pipeline for IPYNB file. JSON-L file. I have extended that JSON-L file into 2500 pairs so that my data would be trained perfectly on my data set. Okay. Now, after that, I've performed analysis on my JSON-L file. All my analysis is being performed on dataset for the JSON-L file. As you can see here in the JSON file, we have an instruction and output and what is the intent of it. So as I've told you, there is a cancellation policy, there is local custom safety, destination comparison. Like this, there are different sections where our instruction would be focused on. And whether and for this instruction, what would be the exact output or the response that my LLM would be giving is what a demo output here. The column set data information missing values. There would be no missing values because I have generated my data set. Coming to that, and next comes the variable description and unique values. Of course, almost all of them would be unique. And in the data wrangling, I did just uh, data wrangling. That is, dropping the duplicates, and I have no duplicates, and stripping the white spaces. That is trailing the spaces, and remove any rows with empty text. And I'll not have any empty rows because that is a clean data set that I have generated. And a soft cap on output because we cannot always generate all the output because our tokens would be exhausted for each response. So I put a cap on my response. So the first chart is I've been having 6 classes in my data set. Hotel booking help, 6 itinerary plans, destination comparison, budget estimation, local custom safety, and cancellation refund support. In my tourism GPT, my data set would be focusing and my GPT would be focusing on these 6 areas. So whenever a customer asks about a question regarding these 6 areas, my GPT would be revolving in that area only to give a specific answer related to the domain. I don't want my data to be outward of this data. So I've trained that. Next comes chart about intent prompting and distribution of word count and distribution of output word count and instruction word count by intent. As you can see here, the average is around 15. And the chart 6 is the output word count for each section. And the next chart is the instruction versus output count. So how many letters I am giving as input and how much output in the letters I'm getting. That is the comparison. Next comes the chart 8, that is top 20 instructions per word. What kind of words are, what is the frequency of the number of words that is there? As you can see, the word trip is being used more in my LLM data sets. And the next chart comes for when a data set is giving an output, what kind of output words are giving in the most frequency. As you can see, it ranges up to 2500 and it's giving a specific word day as a most outputted word in the for my chatbot. Next comes chart 10. As you can see, what are the most frequent words used? As I've told you, the day, hotel, trip are most used. And next comes the word intent, but this is with respect to their each 6 different segments. As you can see here, safe, local, day, hotel, need, money, refund, booking is mostly used in their specific sectors. As you can see here, and what are the two pair words that are used most in my input instructions? That is day trip or compare hotels is what my client is giving to the as an instruction to my chatbot. Next comes the chart 13, that is about the mean word count. And next comes the heat map about the instruction count. And next comes the pair plot, general pair plot, and hypothesis testing as well. I've done basic 3 hypothetical trainings. as my instruction word count differs significantly across intent classes. That's been rejected. I'll show you next. And destination comparison outputs are significantly longer than other intents. That is rejected as well. All these intents have been rejected because of low p-value. Okay, as you can see here, for the first one, I've used a one-way ANOVA test, but the p-value is 0. And for the second one, I've used Welch-Hoffman's technique, and for that as well, my hypothesis is rejected. And for the third one, I've used chi-square test for that, and for that also my chi-square value is 0. All my hypothesis is been rejected. And in the feature analysis is what I've did is in the first sections as well, all the categorical encoding and textual pre-processing. I've removed all the unnecessary words that are there in my textual, so that only keywords that are there in my data set would be captured by my LLM, and would be processing that to give a specific output for my chatbot for travel. All my letters have been lowercase for instructions. See here, you can see here. And I have removed all the URLs and all the stop words that are removed earlier, as I've showed you in the upper slides. And no rephrase text, and to tokenization for the small words are being completed, and text normalization using lemmaization techniques, and the text vectorization as well for TF-IDF technique, and feature manipulation as well for what are the features that are required for my LLM output. Data transformation, data scaling, and data splitting respectively. And in the ML model implementation, I've used three models again. The first one is logistic regression, as you can see, and this is my logistic regression confusion matrix, and the accuracy is 0.91, and the weighted F1 value is 0.91. And for the first one, I've did grid search CV. And the second model is for random forest. And in the random forest, I've got accuracy as 0.93, and weighted F1 value is 0.94. And for this also, I used randomized search CV threefold technique. And for the third model, I used linear SVM technique. Coming to that, and as you can see, for that my average is 89%, and weighted average is 89%. So as you can see, we are using after comparison, I've been using random forest as my model because the accuracy is higher compared to all these three models. These are what the features that are given in my six different models per intent, which are in the top 15 words that are used. And next comes yes, after doing this, before conclusion, what I wanted to do is to prepare my LLM, I need to tune my model. So as you can see here, my uh, tourism GPT is being tuned based on uh, the GitHub Onslaught techniques. I've imported all my required data sets for my data set and Hugging Face as well. For that, I've used a PHI-3 model as my base model to train my model. After that, and after mounting my data and importing my data set, I would be receiving to uh, the object. I'm loading PHI-3 model as I've told you earlier. In the model name and all, the data set would be loaded here. And I've loaded all the 2200 trainings examples for from the JSONL structures. And I've been training the model with their epochs. As you can see here, my epochs has been and the training loss values are present here, and my data would be finished. And I'm also giving a few example questions so that I would see whether my data set is performing correctly or not. And for the question given, and I've been receiving receiving my answers, and how many tokens are for my max tokens and max length that I have to provide for my output from for the model is what I've been provided here. So after this, what happens is I need to provide my RAG model. This is what I've told you earlier, that I would be using another model in another data set input in my uh, RG pipeline. So what I've been doing is this wiki voyage is what I've been using. So what this wiki voyage is exactly that wiki voyage dump provides an up-to-date knowledge about destinations and attractions. So based on that, my data model would be tuned so that my output would be presenting and would be there in my circle of travel only. So I wanted to tune that model based on my NVK voice. This is a BZ2 file, XML BZ2 file. I will be providing this link as well, so that uh, providing this link would be we cannot upload this in my GitHub because it is a large file around 140 MB. So rather than uploading this in it into my drive or for loading, rather we can download it into my local device, and we can connect it to the drive. So after that, after mounting my file, I would be parsing my wiki voices so that I would train the model for my data set. As you can see here, there are 5,000 articles based on the conversations of travel for my data set, and for my travel GPT model. I have been loading the models. This is a warning, so we can ignore torch because that is not present in my local LLM. So that can be ignored. All the 18,000 embedded files and chunks are loaded. Uh, so what exactly happens is my 5,000 would be loading into tokenizers, and would be giving as embedded chunks for output, so that my LLM would be processing, and ChatGPT and my Tourism GPT would provide exact output based on the specific chunk of my instruction given for my model. So I have also wanted to check whether my model is retrieving my exact data or not. For that, I provided few instruction questions, and it is giving exact model based on the same instruction. As we can see here, this is taking now 400 tokens rather than 300, and 4,909 and 4,096 as the max output length for characters that my output can be given. So this is the output that is tested, and it is giving a long answer as well. As you can see here, for the Japan answer, it's giving a long answers from my model. Okay, and next comes my UI. This is basically where our FAISS model is being loading from our rack pipeline into our GPT, so that our front end is loaded. For the front end, I've been using Gradio because Gradio is best for showcasing and displaying our models. So and also Gradio models would be live for a week when the model is run. So it would be easier for any user when he wants to test in the local settings, or in the upcoming uh, if he wants to work for specific days, on specific number of days. Gradio would be useful. And as you can see here, I'm loading it from my drive, all the adapter values and embedded models, all the mini model, wiki voyage, and GPT models into the model, and I've been giving the output as a Gradio uh, Gradio front end, and I've been running the model. This is I've run this in uh, just right now, and we would be getting our tourism GPT, and now also we will be also seeing these few questions. These are pre questions that I already have. And let us say what are the best things in Rome, and I will ask my GPT model. It is processing with my loading into my LLM model, and it gave me a suggestion that in my itinerary, what are the best things to do in Rome if for the day one, day two, and day three. And let us say let us ask one more question. And what is if Bali is safe for female travelers or not? And before that, it also showing me what are the sources that from my model that it is taking. And let us say for Bali as well, if it is working or not. As you can see here, if Bali is safe for female travelers or not, what should female travelers do so that people would feel safe, women would feel safe, so that research local customs, dress accordingly, and respect local traditions from your government. Always check travel itineraries, keep copies of important documents and sources for Bali. So this is the front end, and that conclusion is where I have trained my uh, model, local LLM using PHI 3 model based on Hugging Face models and datasets for my local LLM that is running totally offline. So yeah, thank you.